Hey there, Python programmers, and welcome back to Brad Codes. Today we're going to be talking on a very important topic called closures. And it has nothing to do with breakups. Closures are a very computer science principle in general, so this is not something specific to Python, but we certainly can use it. Most simply defined, a closure is a function that returns a function. And as we see here, we have an outer function with an inner function defined in it, and then we return that inner function. So this is, in its essence, a closure. Now, why might we want to do this? This is a great question, and it has a lot to do with scope and also binding. So as we see in the notes here, we kind of say that the outer function has maybe a variable. Again, we are taking in a parameter of x. So at some point, Python has to store that value of x in memory. Well, that value is going to be bound and accessible by our inner function because again we see that it's dependent, it needs the value of x. So once our outer function is executed right here in line 19, we execute that outer function, we pass 10 in as an argument, and then we set it equal to closure. So if we follow along, we're going to take in x as 10. We're going to create this new function and we're going to return this function. And now what has happened is the value of x of 10 is saved in memory. Now the outer function that took that as an argument is executed and done. But the magic of closures is, again, because the inner function needs it, it is going to keep access to that x variable, even though the function it was created in is already closed. Again, Python sees that, hey, you still need the x variable, so I can't, clean that out of memory. I've got to keep it there so you can access it. So now we see here when we invoke closure, and again, closure is the inner function saved to it. So it's stored in that variable. When we invoke it, that function is executed. So here we pass in 5. We're going to get 15, and for the next one, we'll get 30. And again, the reason for those are, that didn't work right. Sorry. Run it one more time. There we go, 15 and 30. And again, the 10 being saved to x is preserved and bound permanently to that variable. Really, it allows us to make a private variable because again, once x has been created, the only way we can interact with it is using that function. Let's go ahead and code something out together to hopefully make this sync home. And so I'm going to make the counter function. This is a very common use case for closure. Again, we're going to take in a start, and then we're going to initialize count to that start. And in fact, it sounds like this should potentially maybe be a default variable. I think that would be helpful because what we can do, set it equal to 0. So no matter what, we'll always have cool. And now what we'll do is boom, boom, boom. Cool. Next off, let's define an inner function. Let's call it increase count. This is going to take in a value. Now, what we're going to want to do in here, a couple things. First of all, we need to use this keyword non-local count. And if we remember back to learning about scope, scope is function based in Python. But here's the thing, we have a function inside of another function. So in the past, we may have used global, but global is going to be out here. That's not what we want. We need to do non-local so that Python knows count as we have it right here is not a new variable because ultimately we want to, increase it. And then we'll just return our count. So that's our inner function. Now we need to return increase count from the outer function. And now we have a closure here. Let's go ahead and check it out. So I'm going to do something like count up equals our counter invoked. Let's use that default argument. So start will be set to 0. And now let's just print count up. Count up by 2 maybe, so we see something. Let's take out these prints for now. Go back down here and let's see what we got. We got 2. So again, we initiated to 0, counting up by 2. Hey, that looks like it's working. For now, let's try maybe just increasing a little more. So we can be 4. And let's give it a run now. So we started with 1, we counted up by 2 to get to 3. Again, we're preserving count. Count still exists. Again, this function, it still exists in memory because it was created by the outer function, so we're able to keep interacting with it. Let's do one more cool thing just because we can. We should know how to do this in Python. There's no reason why we can't have it return true functions. Let's do a decrease count. This will also need to take in a val. Basically, same thing as above, but again, we need to declare non-local because we have a parent function here. Now, what we'll do is we'll return both increase count and decrease count using a tuple. So basically, this counter is going to close over both increase count and decrease count. Kind of neat. What we can then do is tuple unpack, count up, and count down are now variables taking, again, they're storing increase count and decrease count functions. Let's go ahead and try counting down now. We'll do count down, and let's invoke maybe a 4 in it. Gotta spell count right. Control S, give it a run. Oh, whoops, I did not take the minus out there. I even said we just would copy it and change only that. There we go. So we see, we're starting with 1, count up, brings it to 3, count up 4 more, brings it up to 7, and now counting down by 4 brings it back down to 3. So again, this count variable is managing the value of count. The only way we can interact with it is to call one of these 2 functions because they're the only ones that have access to this count after our closure. Hopefully you enjoyed this video and it helped you understand closures a little bit better. Again, it's really important to understand closures because next we're going to talk about decorators, and really they are just fancy ways of defining closures. So hope you enjoyed this video, like and subscribe, and I'll see you in the next one.